The calendar read July 24th, 1943. The waters stretched out 120 miles to the west of Truk Lagoon. Through the periscope, everything appeared slightly blurred, a thin layer of condensation fogging the glass as Lieutenant Commander Lawrence Randall Daspit peered through the crosshairs at something extraordinary, something that would destroy the Navy's most fundamental beliefs about its greatest weapon. Dead in the water below him sat a Japanese tanker, a massive vessel displacing 19,262 tons. The ship lay crippled and defenseless, the dream target every submarine captain hoped to find in his sights. Daspit had already planted 2 torpedoes into her hull, 2 direct hits that had cut her engines and left her powerless. Now came the moment every submarine commander lived for, the final certain kill. The shot would be textbook perfect, point-blank range, a 90-degree approach angle, the kind of geometry that submarine warfare textbooks were written around. Yet what unfolded over the next 60 minutes would reveal something far more terrible than anyone anticipated. Everything about to happen would expose what would become the greatest weapons scandal in American military history. A systematic catastrophe so complete, so deliberate, that American submarines had been going into battle with weapons that functioned properly only one time in 5. For 18 long months, the Pacific War had been fought with a broken weapon. American submariners had been sacrificing everything, their safety, their lives, sometimes their ships, all while wielding tools that didn't work. Japanese merchant fleets had moved across the ocean essentially unmolested, and the men whose responsibility it was to fix this nightmare had done something worse than nothing. They had looked those submariners in the eye and blamed them for the failures. But this day, in these waters, one commander would collect evidence so overwhelming, so undeniable, that even the most entrenched Navy bureaucracy would have to acknowledge the unbearable truth. The Mark 14 torpedo, America's vaunted masterpiece, its most advanced weapon system, was broken at its foundation. It would require one man's relentless investigation, conducted in defiance of direct orders, pursued at genuine risk to his career and reputation, to finally force the truth into the light. The price of institutional failure was being counted not in dollars spent or budgets overrun, but in merchant ships that should have been destroyed, in sailors who should have lived, in a war that stretched longer than it needed to. The calculus of victory was being rewritten in these waters west of Truk, and Lawrence Daspit was about to provide the proof that would transform everything. The story begins on December 8, 1941. Just hours had passed since the attack on Pearl Harbor when Admiral Chester Nimitz issued his command. The submarine force would wage unrestricted warfare against every Japanese vessel. Complete, unrelenting, total. The American submarine fleet entered this new war suffused with confidence, certain in what they believed without question, their possession of the world's finest torpedo. The Mark 14 had emerged from the Naval Torpedo Station in Newport, Rhode Island, a triumph of engineering design. The specifications alone told a story: 20 feet and 6 inches of steel and machinery, 21 inches in diameter, 3,000 pounds of precision instrument. The weapon could travel 4,500 yards at 46 knots when running at high speed, or extend its range to 9,000 yards by cruising at the more economical rate of 31 knots. Each single torpedo represented an enormous investment, a price tag of $10,000 in 1931, which meant roughly $180,000 in the currency of later decades. More money than a person could spend on buying 15 brand-new automobiles. This was not ammunition to squander on tests and experiments. The warhead alone carried 643 pounds of the most advanced explosive compound available, Torpex. But the real revolution lay hidden within the machinery: the Mark 6 magnetic influence exploder. This device, developed in complete secrecy beginning in 1922, worked on a radical principle. Rather than requiring the torpedo to strike the hull, the magnetic mechanism would sense a ship's magnetic field and detonate underneath the keel, where armor plating offered no protection. The theory was elegant. The explosion would form a massive cavity of gas, a void so enormous it would literally snap the ship's spine. Navy planners believed absolutely in the potential. A single successful hit could destroy even a battleship, the mightiest warship afloat. Their confidence ran so deep that they had authorized exactly 2 full-scale firing tests to prove the design. Both had occurred on the same day, May 26, 1926. The first had been a complete failure. The torpedo had glided silently beneath the target vessel and vanished into the deep. No explosion, no detonation, nothing. The second test had succeeded, deliberately sinking the former submarine USS L-8, which the Navy had specifically removed from active duty and designated for sacrifice to this experiment. Then nothing. For 17 consecutive years, through the Great Depression, through the rise of Japan's imperial ambitions, until December 1941, when America entered the war, not a single additional live fire test was conducted. The reasoning was brutally straightforward. Money. Wartime budgets had been slashed and strangled throughout the 1930s. Congress had systematically cut Navy appropriations. The Naval Torpedo Station employed 3,000 workers laboring in 3 rotating shifts, day and night, year after year, and despite this round-the-clock effort, production barely reached 1.5 finished torpedoes daily. The shortage was so severe it had begun before the war even started. By January 1938, the backlog of unfilled orders had reached $29 million. There existed neither the funds nor the supply to sacrifice weapons on destructive testing, so instead the Navy pursued a different approach. They tested using training warheads, scaled-down versions that were much lighter. These practice torpedoes would float safely after their fuel depleted, allowing crews to recover them, inspect them, and certify them perfect. The magnetic exploder itself was validated in stationary laboratory tanks filled with still water, controlled conditions far removed from ocean chaos. The results looked flawless. Every test passed. The Bureau of Ordnance declared the Mark 14 certified and ready for combat operations. No one seemed to consider that weapons developed in controlled laboratory environments and tested with dummy warheads might behave very differently when fully loaded and firing in actual ocean conditions. On December 24, 1941, just 16 days after the war began, Commander Tyrrell Dwight Jacobs was commanding USS Sargo when he encountered 2 Japanese merchant vessels. He fired 8 torpedoes in sequence. 0 struck their targets, 0 detonated. Jacobs was certain, absolutely certain, that his fire control calculations were correct. He had shadowed one target for 57 minutes straight, verifying his solution repeatedly before committing to the attack. 8 weapons had yielded nothing but disappointment. 1 week prior, on December 14th, USS Seawolf had already reported something troubling. Their torpedoes were sinking far below their set depth. The commanding officer estimated they were passing 10 to 15 feet beneath the targets, far too deep for the magnetic mechanism to sense the ship's electromagnetic signature. Too deep even for a direct physical impact. The reports kept arriving. USS Sargo was the first to document a premature detonation, a torpedo that had exploded halfway to its destination, detonating in open water to accomplish nothing. USS Skipjack reported difficulties. So did USS Stingray, USS Sturgeon, and ship after ship. Patrol area after patrol area, every commanding officer sent the same urgent message back to base. Something was catastrophically wrong with these weapons. Torpedoes were running beneath their intended depths. Some were detonating before reaching their targets. Others were failing to detonate entirely. And most horrifying of all, some were turning in the water, curving back toward the submarines that had launched them. By June 1942, American submarines had expended over 800 torpedoes in actual combat situations. 80% had not worked. Out of every 10 weapons fired at an enemy vessel, 8 had either missed, malfunctioned, or refused to explode. The implications were mathematically catastrophic. Submarines should have been decimating Japan's merchant fleet, sinking cargo vessels by the dozens, strangulating the island empire's supply lines. Instead, Japanese convoys transited across the Pacific with relative safety, while American submarine crews, brave men in deadly vessels, were sacrificing themselves with weapons that betrayed them. The commanding officers understood clearly that something was profoundly broken. They compiled meticulous reports documenting each attack, cataloging every malfunction, recording every failure. They formally requested investigations. They demanded that tests be conducted. The response from the Bureau of Ordnance was consistent, uniform, and insulting. The problem, they insisted, was not the torpedoes. The problem was the men commanding them. These officers were making poor tactical approaches. They were miscalculating their firing solutions. They were neglecting proper maintenance of the weapons. The Bureau of Ordnance had designed the Mark 14. The torpedo station at Newport had manufactured it. 2 decades of research and development had gone into its creation. The possibility that something was actually wrong with the weapon, simply unthinkable. The responsibility, they concluded, had to rest with the men using it. At Pearl Harbor, Rear Admiral Thomas Withers held the position of Commander Submarines Pacific. When his submarine captains arrived with complaints about torpedo failures, Withers sided with the Bureau of Ordnance and dismissed the concerns. When they insisted something was wrong, Withers blamed them for insufficient initiative. The torpedoes, he explained, were scarce and precious. They could not be wasted on field testing. The board had already declared the weapons sound. Discussion finished. One man, however, was actually listening to what the submarine commanders were telling him. Rear Admiral Charles Andrews Lockwood was different. Born in Midland, Virginia, on May 6, 1890, Lockwood had entered the Naval Academy in 1912 and graduated with his officer's commission. His path to submarines began in September 1914, when he reported aboard the tender USS Mohican for training in submarine warfare. By December 1, 1914, he was commanding USS A2, the Navy's second-ever submarine. Lockwood had devoted nearly 30 years to submarines. He knew the men who commanded them. He understood their abilities, their judgment, their experience. When submarine captains with decades of command experience all reported identical failures, Lockwood was paying attention. He believed them. In May 1942, Lockwood took over as Commander Submarines Southwest Pacific Area, operating from Fremantle, Australia. Immediately he found himself drowning in reports of the Mark 14 nightmare. His submarine captains were describing catastrophic failure rates. Japanese ships that should have sunk were escaping to port. American submarines were accomplishing almost nothing, despite exposing themselves to terrible danger. Lockwood understood something fundamental. The Bureau of Ordnance would never authorize official testing. The torpedoes cost too much. The supply was too constrained. But Lockwood also understood something equally important. Sending men into combat with defective equipment was infinitely more expensive than testing, both in lives and in tactical failure. In June 1942, Lockwood did something audacious, something that violated direct orders from higher authority. He conducted unauthorized tests of the Mark 14 torpedo in direct violation of Bureau of Ordnance regulations and explicit prohibition. He was gambling with his career, but he was determined to discover whether the torpedo really did run deep. Captain James V, Lockwood's chief of staff, devised an elegantly simple testing method. They would fire torpedoes through fishing nets that had been suspended at precisely known depths in Frenchman Bay near Albany, Australia. The impact points would show exactly how deep each torpedo was actually running compared to its setting. On June 20, 1942, USS Skipjack fired a single torpedo equipped with an exercise warhead from a range of 850 yards. The torpedo had been set to run at 10 feet depth. Theoretically, it should have passed through the net at exactly 10 feet. Instead, it tore through the net at 25 feet. 15 feet deeper than its setting. It was decisive evidence. The following day, James V personally oversaw 2 additional test shots. Both torpedoes were set to 10 feet. Both passed through the nets at approximately 21 feet, 11 feet deeper than their settings. The pattern was unmistakable. The Mark 14 was running dangerously, significantly deeper than it was supposed to. Lockwood immediately transmitted his findings to the Bureau of Ordnance. The response came quickly and with complete dismissal. Lockwood's testing methods were not scientifically rigorous, the Bureau claimed. Using fishing nets was an unreliable procedure. The problem, they insisted, had to be improper torpedo trimming by the submarine force. They rejected the evidence outright. Lockwood ran the tests again. 3 torpedoes, all set at 10 feet. All 3 passed through nets at 21 feet. Still, the Bureau of Ordnance refused to acknowledge what the evidence clearly showed. Their own tests in Newport had detected no depth problems. Whatever was happening must be the submarine force's fault. Admiral Ernest Joseph King, the chief of naval operations, had grown tired of bureaucratic resistance. King was not a man inclined toward patience with institutional obstruction. He directly ordered the Bureau of Ordnance to conduct their own comprehensive tests immediately. Finally, in July 1942, the Bureau began testing at Newport. By August 1942, more than 8 months into the war, the Bureau of Ordnance officially conceded. The Mark 14 torpedo did indeed run 11 feet deeper than its depth setting. The cause, investigators discovered, was actually a sequence of interconnected design flaws. During development, the torpedoes had been tested using lightweight training warheads. But when loaded with actual combat warheads containing 680 pounds of explosive material, the heavier weight naturally caused the torpedo to sink lower in the water. The vehicle's trim changed, its depth changed with it. That was only the beginning of the problem, however. The depth control system relied on a pressure sensor that measured the water pressure to determine depth. During testing, this sensor had been mounted in the torpedo's conical tail section. But at high speed, 46 knots, the water flowing around that conical shape created a low-pressure pocket. The sensor misinterpreted this artificial low-pressure condition as shallow water and commanded the torpedo to dive deeper to find its target depth. The faster the torpedo traveled, the deeper it would run. A single full-load test would have revealed this immediately. That test had never been conducted because destroying a fully armed torpedo was considered wastefully expensive. By August 1942, the depth problem was finally identified and acknowledged. The Bureau issued corrected calibration instructions. Submarine crews were told to set their depth mechanisms for 0 depth, compensating for the known 11-foot error. Leadership believed the problem had been solved. It was not. With torpedoes now running at approximately the correct depth, a different catastrophe emerged. Premature detonations. Torpedoes were exploding before they reached their targets. The detonations occurred hundreds of yards short of Japanese ships. Submariners could watch through their periscopes as their weapons lit up the ocean in useless explosions, detonating harmlessly in empty water. The magnetic exploder was triggering far too early. On April 9, 1943, Lieutenant Commander John A. Scott was commanding USS Tony when he found himself in a situation every submarine captain dreams about: a perfect firing position against 3 Japanese aircraft carriers, Hio, Junio, and Tio, all within just 880 yards. This was essentially point-blank range for a submarine assault. Scott worked quickly and fired all 10 torpedo tubes. 7 explosions shook the water around the carriers, but as Scott watched, none of the carriers showed any visible damage. None slowed down. All 3 continued steaming at full speed. Later intelligence analysis confirmed what Scott probably suspected. All 7 of his torpedoes had detonated prematurely, the magnetic exploder triggering too soon, none of them reaching their targets. On April 10, 1943, USS Pompano attacked the aircraft carrier Shokaku, firing 6 torpedoes at the vessel. At least 3 exploded before reaching the ship. The carrier emerged completely undamaged. On June 10, 1943, USS Trigger engaged the aircraft carrier Hio, launching 6 torpedoes from 1,200 yards out. The first torpedo whistled past the target, completely missing. The second detonated far too early, ripping through the water before reaching its mark. The third simply failed to explode at all. 2 others struck home but delivered barely a scratch. Yet somehow the carrier limped away, damaged but alive, heading back toward port. The truth stared everyone in the face. This pattern kept repeating. The magnetic exploder simply could not be trusted. After months of denial, the Bureau of Ordnance finally broke its silence on April 27, 1943, acknowledging what submarine crews already knew. The Mark 6 exploder was prone to detonating prematurely when operating at shallow depths. The Bureau's solution came with strings attached. They suggested abandoning the magnetic feature entirely and relying instead on contact detonation. Yet they wanted something else too. They demanded extending the arming distance from 450 yards all the way out to 700 yards. They also insisted submarine captains fire only under very specific tactical situations that would supposedly reduce premature explosions. Admiral Ernest King would have none of it. 700 yards was too far. Submarines had to get dangerously close to their targets to guarantee success. King sided with Lockwood on this crucial point. The magnetic exploder needed to go. By June 24, 1943, Admiral Chester Nimitz had seen enough. He issued orders throughout the Pacific Fleet. Every submarine would shut down its magnetic influence exploder immediately. Only contact detonation would be used from that point forward. 18 months into the war, the Navy finally admitted the magnetic exploder was fundamentally broken. Yet the reality was even more damning. The Bureau of Ordnance had built these flaws directly into the design from day one. The weapon was guarded so zealously that submarine captains were not even permitted to look at it. The Bureau had established strict protocols. Torpedo workshops would paint over all screws securing the exploder mechanism. Any sign of tampering would show immediately on the paint job. Submarine commanders were effectively forbidden from examining the very weapons they were putting their lives on the line to deploy. But submariners have always been a resourceful and independent breed. Maintenance crews at the submarine bases developed their own system. They would casually ask the paint shop which color was being applied that week. Upon learning, say, that blue paint was the standard, they would obtain matching blue paint of their own. Working carefully, they would open the exploder mechanisms, make their own internal fixes, and then meticulously repaint every screwhead. When the torpedoes went back for official inspection, not a trace of their work remained. By mid-1943, commanders all across the Pacific were quietly making these modifications themselves. They were also changing their patrol reports, claiming enemy vessels were larger than they actually were so they could justify firing more torpedoes. They lied to their commanding officers because the alternative meant dying without any real chance of success. One submarine area commander refused to go along with this quiet rebellion. Rear Admiral Ralph Waldo Christie, who commanded submarine operations in the Southwest Pacific, insisted his boats continue using the magnetic exploder. The reason was deeply personal. Christie had been the engineer who developed the Mark VI exploder back in the 1920s and 1930s. He had invested years perfecting this device. His entire reputation rested on its success. Despite overwhelming evidence that the system was failing, Christie simply could not accept that his creation was fundamentally flawed. He commanded his submarines to keep using it. His captains were seething with resentment. They watched their torpedoes either detonate too early or fail completely while submarines under Lockwood's control, now operating without the magnetic feature, were actually destroying Japanese vessels. Christie's fleet continued suffering terrible failure rates. Meanwhile, Lockwood's submarines were sending Japanese ships to the bottom. Finally, in November 1943, Admiral Thomas C. Kinkaid, commanding all Allied naval forces in the Southwest Pacific, issued a direct order. Christie had to disable the magnetic exploder in his area. There was no room for argument. Yet even after solving the depth problem and turning off the magnetic system, torpedoes remained unreliable in a different way. Submarine captains began reporting something alarming. Their torpedoes were striking targets and simply not detonating. Duds. On July 24, 1943, Lieutenant Commander Lawrence Daspit, commanding USS Tenzona, stumbled upon what every submarine captain dreams of finding: a massive 19,262-ton tanker sailing completely alone with no escort. Intelligence officers had intercepted messages about this vessel's route and timing. Tenzona was positioned perfectly. At dawn, just after 5:55 in the morning, Daspit spotted Tonanmaru No. 3 steaming directly toward him. By 9:28, with the target firmly in his sights, Daspit launched 4 torpedoes from nearly a mile away. The sonarman heard 4 distinct metallic thuds echoing through the boat as each torpedo struck the tanker's hull, but only 2 explosions followed. Those blasts tore into the engine compartment. The ship shuddered to a halt, tilting dangerously to one side. Daspit saw his opportunity. With the target sitting motionless and helpless, he had time to set up the perfect follow-up attack. He maneuvered Tenzona to exactly 875 yards from the tanker's side, positioning his boat perpendicular to the target. This was the textbook firing position, the geometric perfection every commanding officer trained for. This was how victory should come. At 9:30, Daspit fired his fifth torpedo. It cut through the water in a straight line, its wake marking a path like a deadly finger pointing at the doomed vessel. The torpedo struck, a hollow thud. Nothing else. Daspit stared in disbelief. He fired torpedo number 6 immediately. Impact, no explosion. Torpedo 7, impact, silence. Torpedo 8, the same maddening result. Daspit ordered his torpedo officer topside to the control room. Together they examined the remaining weapons loaded in the tubes. Every detail appeared flawless. Maintenance logs showed these torpedoes had been carefully serviced. Depth settings were precise. Contact exploders were properly armed. There was no mechanical reason for what was happening. Daspit sent another torpedo downrange. Hit, no detonation. Number 10, strike, failure. Number 11. Another ghostly thud. Daspit sat down to write in his patrol report what he had just witnessed. This weapon struck the port side toward the rear, made a spray of water as it hit, then somehow rotated sideways and leapt clear out of the ocean, about 100 feet beyond the ship's stern. I struggled to convince myself of what I saw with my own eyes. A Japanese destroyer appeared on the horizon. Depth charges began hammering down. Daspit had to dive for safety. Before he went deep to escape, he fired his last 4 torpedoes in desperation. Number 12, direct hit, dead. Number 13, impact, nothing. Number 14, strike, dud. Number 15, final torpedo, impact, silent failure. Daspit had fired 15 weapons, 11 had found their mark, only 2 had actually detonated. The tanker escaped. Daspit possessed just 1 torpedo left. He made a decision that would reshape naval warfare. He would preserve that final weapon and return it to Pearl Harbor for examination rather than waste it on a target that apparently could not be sunk. Daspit plotted course for home, recording in his log words no submarine commander ever wanted to write. He was returning empty-handed. USS Tenzona pulled into Pearl Harbor on August 4, 1943. Daspit rushed to Submarine Force headquarters. Rear Admiral Charles Lockwood, who had taken command of submarines in the Pacific after Robert English died in a plane crash on January 21, 1943, came out to meet him. Lockwood had braced himself for an explosion of rage. He later reflected on the encounter. I was prepared for a torrent of profanity, condemning me, condemning the Bureau of Ordnance, condemning the Newport torpedo facility and our own torpedo shop. I could not have faulted him for it. 19,000-ton tankers do not appear by chance. I thought Dan must have been so furious he could barely speak. But Daspit remained composed. His fury had transcended anger entirely. He simply laid out the facts in measured tones. 15 weapons fired, 11 confirmed direct hits, 2 explosions. A target sitting completely still in the water that escaped because American torpedoes failed. The single torpedo Tenzona had carried back arrived at the submarine base torpedo shop. Technicians worked through it methodically and completely. They found 0 defects. According to every specification, the weapon should have detonated on contact. Lockwood understood waiting was pointless. The Bureau had delayed action on the depth problem for many months. They had dragged their feet on the magnetic exploder for over a year. They would continue denying the dud problem indefinitely unless confronted with proof so massive that denial became impossible. Lockwood decided to launch his own inquiry, again without authorization, again in violation of regulations, again risking everything. He assigned Commander Art Taylor, his gunnery and torpedo specialist, to arrange actual combat tests. They would fire real torpedoes carrying full combat warheads under conditions replicating genuine combat scenarios. Lieutenant Commander Sild Mommsen volunteered to assist the investigation. Mommsen was already a living legend throughout the submarine fleet. Back in 1939, Mommsen had orchestrated the rescue of 33 men trapped in the sunken submarine USS Squalus. He had invented the Mommsen lung, a device that had preserved countless lives. Mechanical systems were his expertise. Testing protocols were his domain, and he recognized clearly that the Mark 14 was destroying American submarines. Taylor and Momsen studied maps of Hawaiian waters extensively, hunting for an ideal test site. They needed cliffs that plunged vertically into very deep water, with sandy bottoms where failed torpedoes could be recovered and examined. The island of Kahulawe, a tiny uninhabited speck southwest of Maui, possessed exactly what they needed. On August 31, 1943, USS Muskaluge fired 3 combat torpedoes with full warheads directly into Kahulawe's rocky cliffs. The first 2 detonated properly. The third remained silent. Momsen himself descended into the water to inspect the failed weapon. It lay in 2 separate sections. The warhead cracked completely open. The explosion mechanism had simply not triggered. The crew carefully recovered the broken torpedo, placed it on a barge, and transported it back to Pearl Harbor. Once the warhead was safely disconnected, Momsen and his team disassembled the entire exploder mechanism. What they discovered was shocking. The firing pin had been released from its catch, but it had not traveled nearly far enough along its metal tracks to generate sufficient force striking the primer. The collision with the cliff face at 46 knots had mangled this fragile component beyond its ability to function. Higher velocity impacts made jamming more probable. The harder the torpedo struck, the less likely the firing pin would successfully trigger the detonation. The most dangerous collision angle, the perfect 90-degree strike that captains trained their entire careers to execute, was precisely the circumstance most likely to produce failure. Momsen could not test this theory by spending more expensive warheads against rock walls. Lockwood approved a different method. Art Taylor directed construction of a specialized testing apparatus. A crane arrived from the Pearl Harbor ship facilities. Dummy warheads were filled with sand to replicate the weight characteristics of actual explosives. These were then dropped from 90 feet above a steel plate positioned at different angles. 90 feet was not arbitrary. It had been precisely calculated. A warhead released from that height would impact at identical velocity to a torpedo traveling at 46 knots. The findings were alarming. When warheads struck the plate straight on, at perfect right angles, 7 out of every 10 failed to explode. A 70% dud rate. When warheads hit at 45 degrees, a glancing impact, only 5 out of 10 failed. Oblique strikes performed twice as effectively as perpendicular ones. The explanation became evident. The Mark VI firing pin mechanism lacked the structural strength required. It had been engineered for slower torpedo designs. Earlier Mark III exploders from the First World War had suffered from identical problems. Impact forces would jam the firing pin sideways in its housing, preventing the strike against the detonator cap. The fix had been obvious to designers in the 20s. Install a stronger spring. But when Mark VI exploders were developed during the 1920s, those earlier lessons were completely ignored. The designers created an even more fragile mechanism. The speedier Mark XIV, moving at 46 knots rather than 30, generated impact stresses the firing pin assembly could not survive. Every submarine commander had received instruction that a 90-degree approach was the supreme tactical maneuver. Training emphasized this geometry as the highest form of attack excellence. Yet this was the very angle producing the worst performance. The Navy had been drilling submarine captains to execute the single attack configuration most prone to failure. Lockwood transmitted urgent orders to all submarines in his command. Stop attempting 90-degree firing angles. Execute oblique approaches instead. Aim for 45 degrees or shallower. The instruction seemed backwards to every submarine captain. It violated their entire training foundation. It complicated attack procedures. Yet the changes slashed the failure rate dramatically in half. The oblique firing orders accomplished something else as well. They demonstrated conclusively to the Bureau of Ordnance that the problem was genuine. Submarine commanders were not incompetent. The torpedoes were broken. Lockwood recognized the oblique firing guidance was only a temporary measure. The firing mechanism required a complete overhaul. Problem was, the Bureau of Ordnance held tight control over every single torpedo modification. The Bureau wasn't about to admit yet another failure. Lockwood decided he couldn't wait for permission anymore. He directed the USS Holland, a submarine tender, to start manufacturing redesigned firing pins right there in the shipyard. The approach was brilliant in its simplicity. The Mark VI torpedo's original design featured a heavy steel firing pin block. When that block slammed into something with tremendous force, its own weight would cause the firing pin to stick, preventing detonation. A young lieutenant named E.A. Johnson, working with Taylor overseeing the project, engineered a solution using a lighter firing pin block crafted from aluminum alloy instead. Where did they find the aluminum? It came from an extraordinary source: destroyed Japanese aircraft salvaged after the Pearl Harbor attack. The submariners understood the irony immediately. They were rebuilding broken American weapons using metal stripped from their enemies' planes. Johnson also created an electrical firing switch to replace the mechanical firing pin system. Both innovations proved effective. Manufacturing them presented no major obstacles. On September 30, 1943, the USS Barb left Pearl Harbor carrying 20 torpedoes, each one equipped with the new aluminum firing pins built aboard the Holland. What happened next astonished everyone. Barb's torpedoes actually worked. By mid-October, the Holland had manufactured enough modified pins to outfit every submarine heading out on combat patrol. Nearly 2 years after war began, American submarines finally possessed functioning torpedoes. The impact proved immediate and profound. During 1942, American submarines had fired 1,142 torpedoes with disappointing results. Later investigation by the Joint Army-Navy Assessment Committee uncovered the real numbers: 134 ships totaling 580,390 tons destroyed. The actual success rate fell far short of wartime optimism. By 1944, everything changed. With reliable torpedoes, American submarines sank 492 ships, amounting to 2,387,180 tons. In 1945, they destroyed 132 ships, totaling 469,872 tons. The decline reflected depleted targets rather than reduced effectiveness, as the successful campaign had systematically devastated Japan's merchant fleet. The once troubled Mark XIV torpedo transformed into one of the Pacific War's most formidable weapons. American submarines ultimately sank 1,300 Japanese vessels, totaling 5.3 million tons. They obliterated 60% of Japan's merchant marine. Their stranglehold choked off every supply route reaching the home islands. Beyond merchant ships, they sank 8 aircraft carriers, 1 battleship, and 11 cruisers. They accounted for 55% of all Japanese shipping destroyed. Yet this triumph demanded a horrifying price. The submarine service experienced casualty rates exceeding every other American military branch. 1 in 5 submarines that departed never returned. 52 submarines were lost completely. 3,505 officers and men perished. Many fell during those first 2 years when torpedoes refused to function. No one could say precisely how many submarines died because their weapons failed at the critical moment. No one would ever know how many submariners gave their lives making repeated attacks on targets that a single working torpedo should have destroyed. How many enemy ships escaped to later devastate American forces because submarine torpedoes proved unreliable? These unanswered questions tormented Lockwood throughout his remaining years. In September 1943, after the torpedo crisis finally ended, Lockwood termed it V-Day for submarine warfare. From that September 30th forward, American submarines became genuinely formidable weapons. Yet Lockwood carried the weight of wondering what could have been. He reflected years afterward that proper testing before hostilities began would have delivered weapons that functioned correctly. The entire war might have concluded sooner. Thousands of lives might have been preserved. The Bureau never formally acknowledged responsibility. In their post-war review, they confessed that testing had fallen dangerously short. They conceded production protocols were inadequate. They admitted torpedoes were engineered for painstaking, limited production, unsuitable for massive wartime manufacturing. The Bureau's concluding statement expressed deep regret. Even with modest peacetime resources, much of what they'd accomplished after 18 months of combat could have and should have been completed years earlier. That the work remained incomplete during peacetime and early wartime, the Bureau acknowledged, indicated that no one, neither Bureau officials nor Newport Station personnel, had questioned design inadequacy without proper testing. This represented a troubling lack of practical understanding about the challenges, wholly incompatible with the Bureau's stated standards, and cast serious discredit on both the Bureau of Ordnance and the Naval Torpedo Station. Therefore, the Bureau's leadership decreed that henceforth no service torpedo would ever receive standard adoption until tested under conditions approximating actual combat as closely as possible. It constituted a remarkable acknowledgement, arriving far too late for submariners who'd perished carrying broken weapons. The torpedo debacle exposed deep institutional flaws in Navy weapons development and evaluation procedures. Financial concerns had superseded combat effectiveness. Security restrictions had prevented operators from understanding their own equipment. Institutional ego had obstructed necessary fixes that field officers had identified within weeks of combat starting. The Bureau had devoted 2 decades constructing a torpedo that failed to function. They'd dismissed reports from men who risked everything using it. They'd accused submarine commanders of incompetence rather than confronting design failures. Once problems became undeniable, they resisted every modification, every improvement, every solution. Lockwood emerged as history's hero not because he possessed engineering genius. He became a hero because he heard his submarine commanders. He believed in their knowledge. He gambled his reputation conducting prohibited tests. He circumvented official procedures when the system failed. He assumed personal accountability for correcting defective weapons beyond his formal authority. Most crucially, he rejected sending servicemen into battle carrying weapons he knew were broken. Lockwood's unauthorized investigation at Frenchman Bay during June 1942 established the depth problem conclusively. His unsanctioned tests at Kahula in August 1943 demonstrated the dude problem conclusively. His unauthorized production operation aboard USS Holland in September 1943 delivered the solution that finally equipped American submariners with effective torpedoes. Every initiative breached regulations. Every choice risked court-martial. Every action directly challenged the Bureau, among the Navy's most influential entities. Yet Lockwood grasped something the Bureau fundamentally failed to understand. Weapons exist for one purpose: functioning. Tests serve one purpose: exposing failures. Leadership serves one purpose: solving problems rather than concealing them. By war's conclusion, Lockwood had risen to Vice Admiral. He witnessed the surrender ceremony on the USS Missouri, September 2, 1945. He stood with senior Allied commanders who had vanquished Japan. His submarine fleet had destroyed more Japanese shipping than all other forces combined. The Mark 14 torpedo had become the Pacific's most formidable undersea weapon. Yet the torpedo's ultimate victory stemmed from a single officer's unwavering refusal to tolerate failure. The entire Mark 14 scandal fundamentally concerns inadequate testing. In 1931, a new car carried a $700 price tag. A Mark 14 torpedo cost $10,000. The Navy concluded that torpedoes possessed too great a value for destructive testing. They experimented using dummy warheads. They evaluated the magnetic detonator in laboratory basins. They performed exactly 2 actual tests in 1926, then dispatched the weapon into combat. The testing deficit exacted payment measured in destroyed attacks, lost submarines, dead sailors, and protracted warfare. By 1944, American factories produced 150 Mark 14 torpedoes daily. Total wartime manufacture exceeded 60,000 units. At $10,000 each in 1930 dollars, production totaled $600 million, equivalent to $12 billion today. What expense would adequate testing have required? Destroying several dozen torpedoes through rigorous testing would have revealed the depth malfunction, the magnetic detonator problem, and the firing pin flaw before war commenced. Realistic evaluation would have cost approximately $500,000 in 1930 money, less than a single submarine. Instead, the Navy prosecuted combat for 2 years deploying faulty weapons. Submarine commanders achieved roughly 20% effectiveness when 80% or better remained achievable. Enemy merchant vessels requiring destruction in 1942 continued sailing until 1944. Monthly operation meant continuous supply delivery to occupying forces. Every soldier receiving provisions from those ships possessed opportunity to kill Americans. Every enemy aircraft refueled by those tankers could shoot down American pilots. The calculations prove sobering. Had Mark 14 torpedoes functioned properly from December 1941, the submarine force could have achieved in single year what required 3 years to complete. Japan's merchant marine would have faced destruction by 1943 instead of 1945. Warfare might have terminated considerably earlier, preserving tens of thousands of lives. The entire difference hinged on proper testing. 50 torpedoes destroyed through realistic trials in 1939. $500,000 in expenditure that would have prevented billions in costs and immeasurable suffering. Instead, the Bureau decided testing represented excessive expense. They miscalculated. The expense of insufficient testing proved catastrophic. Military academies today teach the torpedo scandal as instructional history. It presents several fundamental lessons. First, equipment demands evaluation under authentic operational circumstances. Laboratory analysis and dummy warheads cannot replicate combat performance. Second, those operating weapons must participate in testing and creation. Submarine commanders recognized torpedo defects within weeks of war commencing, yet they received no participation in development. Third, institutional organizations must possess capacity acknowledging error. The Bureau spent 2 years denying difficulties evident to every field officer. Fourth, excessive secrecy undermines effectiveness. The magnetic detonator remained so classified that submarine commanders couldn't inspect it. This prevented professionals most familiar with the weapon from recognizing its problems. Fifth, genuine leadership demands listening, honoring expertise, and accepting risk addressing complications. Lockwood demonstrated that authentic leadership requires confronting authority when authority errs and refusing to deploy personnel with equipment known as defective. By September 1943, American submarines possessed functional torpedoes. Everything transformed. Submarine commanders enduring 2 years of disappointments finally possessed reliable weapons. USS Tang, commanded by Richard O'Kane, established an exceptional battle record. USS Barb, equipped with modified firing pins from USS Holland, compiled a legendary patrol record. American submarines patrolled the Philippine Sea, East China Sea, South China Sea, and waters surrounding Japan. They obliterated tankers, cargo vessels, transports, and combat ships. Japan's wartime economy collapsed as overseas resources stopped reaching Japanese factories. Oil originating in the Dutch East Indies, Malaysian rubber, Indo-Chinese provisions, everything traveled by ocean. American submarines with functional torpedoes commanded those waters. By 1945, Japan faced strangulation. Industrial plants operated without essential materials. Population centers experienced food shortages. Military forces lacked petroleum reserves. American submarines had accomplished what neither air bombardment nor naval combat achieved, obliterating Japan's capacity for continued resistance. With an effective weapon, their strikes proved devastating. The Mark 14 torpedo served until 1980. Successive generations produced modifications and enhancements, yet it never would have developed into the lethal weapon it became without Lockwood's extraordinary investigation. One admiral rejecting defective equipment, one prohibited investigation, one test confirming what everybody already recognized: torpedoes weren't working. One decision implementing repairs, disregarding protocols, circumventing bureaucracy, confronting personal peril. Charles Lockwood departed life on June 6, 1967. He reached 77 years of age. His remains rest at Golden Gate National Cemetery in San Bruno, California, positioned among Admiral Chester Nimitz, Raymond Spruance, and Richmond Kelly Turner. Celebrated Pacific War commanders. Leaders transforming setback into triumph. Yet Lockwood's crowning achievement transcended combat itself. His victory emerged from Frenchman Bay's investigation, Kahula's evaluations, USS Holland's production facility. His victory unfolded in Washington conference rooms, confronting authority. His victory existed in every briefing where he genuinely listened to submarine commanders. His victory inhered in each decision, favoring personnel over institutional resistance. His heritage represents the realization that authentic leadership requires bravery confronting power when personnel survival depends upon it. It demands executing investigations everybody claims remain impossible. It necessitates resolving complications everybody insists don't exist. It requires heeding your team when institutions won't. It demands the conviction to withhold personnel from engagement with weapons you recognize as compromised. That characterizes Charles Lockwood's remarkable investigation. That describes how one admiral restored America's damaged torpedoes.